Hey everybody, we're going to wrap up the reproductive system chapter with female reproductive system physiology. So that's going to be our topic starting on page 135 in the course pack. So we're going to walk through oogenesis first, which is very similar to spermatogenesis with a few big exceptions. So the processes both undergo mitosis and meiosis, but the interesting thing here is with oogenesis, primary oocytes are formed before birth. In fact, a female has pretty much her entire lifetime supply of oocytes before she's ever born. So think about this interesting concept. Mom carries a baby, and the baby that she's carrying contain the primary oocytes of her grandchildren. So imagine that what you do as a mom pregnant with a baby can ultimately influence the lives of your grandchildren. That is a really profound thought. The secondary oocytes that are ovulated starting at puberty are made from one oogonium rather than producing four like we see with sperm. So we don't end up seeing 4 cells, viable cells, made as a result of oogenesis. Finally, the secondary oocyte doesn't complete meiosis, it stalls in meiosis too, and only completes if that cell has been fertilized. So there's a lot of profound differences here that we're going to talk about as we move through this process. So let's take a look. The process of oogenesis begins in the ovary, of course, and there's not just an oocyte that we're going to go pass through maturation here. There's also a surrounding follicle. So you'll notice in these images here, there's follicles around each one of our oocytes. It's like this oocyte is such a special cell that it requires its own group of ring bearers, you might say, that surround it. So even down here in this last picture, this mature follicle shows a ring of cells surrounding the oocyte in the center. And so that ring of cells is called a follicle. So we start with an oogonium before a baby is born. Notice that's up here in the embryo. Okay, and the oogonium undergoes mitosis to produce primary oocytes. And it says here that those primary oocytes stop in prophase of meiosis 1. And that's what we have present at birth. Around 400,000 is a number I have seen for the amount of primary oocytes a female baby is born with. Now, those will stall and sit there until that little girl grows up and hits puberty. When she hits puberty, approximately 1 or so of these primary oocytes will start to develop every month. Those primary oocytes will complete meiosis 1, they'll start meiosis 2, but they will stall in meiosis 2 as a secondary oocyte, and they will wait there until fertilization occurs. Now, if after ovulation there is no fertilization event, then 24 hours later, that secondary oocyte dies and it's passed out in a female's vaginal fluids. This process of taking a primary oocyte, turning it into a secondary oocyte, occurs every month. Okay, so this is a monthly process. Begins at puberty, at menarche, which is the onset of menstruation, and it begins, or ends rather, at menopause. So for, approximately 40 or so years of a female's life, every month, except for the years when she's pregnant, she will experience one primary oocyte furthering development into a secondary oocyte. And the only time that secondary oocyte ever finishes meiosis 2 is if there is an ovulation event and fertilization occurs. Now keep in mind, we're looking at follicles developing along with this oocyte. That's part of the story here. So on your worksheet, you'll notice that there are polar bodies that are made. These polar bodies are junk cells, and they are created as a way to get rid of extra DNA that's not needed for this oocyte. You'll also notice the size of each polar body is really small. That's because the cytoplasm and cellular machinery is donated to the secondary oocyte. It needs to be a very large cell because once fertilized, it will undergo cellular division and drift toward the uterus where it may implant and begin a pregnancy. So these polar bodies are donating their cytoplasm and machinery to the secondary oocyte. Those polar bodies cannot be fertilized. They are discarded in a female's vaginal fluids. So the secondary oocyte still is double-stranded. We haven't yet separated those duplicated chromosomes into single-stranded chromosomes, but upon fertilization, that separation would occur. Just for the sake of comparison, you'll notice that on the left we see 4 sperm produced from one spermatogonium. This cell up here at the very top is called a spermatogonium. And the spermatogonia undergo mitosis and meiosis daily, hourly, from the time a male hits puberty until the day he dies. But with females actually have these primary oocytes already present by birth. And these are her oogonia up here. So she already has her primary oocytes developed. At puberty, those will start developing monthly into secondary oocytes. And then the only time we ever complete this process down here is when? Only if fertilization occurs. Okay, so if there's no fertilization, this secondary oocyte right here is the end of the story. Really cool picture here to take a look at. What you're seeing is an oocyte, and it's surrounded by a ring of cells. This ring of cells, you'll notice here, have a set of names, corona radiata and zona pellucida. So here's the oocyte in here, and there's a ring of cells surrounding it here. Those cells have to be penetrated by sperm in order to make the way in and fertilize the egg. Okay, so that is why those sperm carry an acrosome, which is a helmet full of enzymes with lysosomes in there that help to break apart this corona radiata. Now, additionally, there is a follicle, and this structure out here is the follicle. It's a set of cells that surrounds this oocyte. When a female ovulates, this oocyte will be ejected out of this follicle. So if you can imagine how a blister ruptures, that's how the oocyte escapes the follicle at ovulation. A female would have many scars on the surface of her ovaries when these oocytes are ejected every month. So imagine a woman in her 40s, how many scars she would have on her oocytes from these monthly ovulations and ejections of oocytes. Another really cool picture of the follicle surrounding the oocyte. Once again, here is the oocyte, and here, this ring of cells here is the corona radiata. Those cells have to be penetrated by the sperm for fertilization to occur. And then out here surrounding that, on both sides of this picture, that is the follicle that is going to mature along with this oocyte. So again, this picture just shows multiple oocytes at various stages of development. I should mention to you that the process of developing a secondary oocyte takes 2 to 3 months. So the oocyte that is released for ovulation this month may have begun its maturation process 2 to 3 months ago. So you can see when that oocyte is ovulated, it is ejected from the surface of that ovary. So just keep in mind that this is a much more complex process than sperm formation because we're looking at multiple months here leading up to the ovulation process. You can also see in this ovary, you can see other follicles that are in the process of developing. The follicle will mature into what's called a yellow body. That's why they call it a corpus luteum. And when it's ovulated, that cell will escape from that corpus luteum. So pretty interesting process and relationship here between the ovary and its oocytes and follicles. So if you'll follow me to page 136, let's talk about ovulation there. Once a month, a follicle, a mature follicle called a Graafian follicle, will move to the surface of an ovarian rupture, and that's how this oocyte will be ovulated. Now, we're not specific here. Is this a primary oocyte? Or is that a secondary oocyte that's being ovulated? It is secondary. And keep in mind, it finished meiosis 1, but what happens to it in meiosis 2? It stalls. Okay, so it didn't complete meiosis too. Now, what you don't see from this picture is a set of fimbriae from a fallopian tube that will create a current that helps to pull this oocyte down into the fallopian tube. All right, so on your worksheet, let me hit this question for you. It said, number 2, fertilization, if it occurs, usually takes place in the fallopian tube. Why 24 hours? That's how long that secondary oocyte has to live. It will travel for 24 hours down the fallopian tube. If a sperm encounters it, then of course fertilization can occur. After 24 hours, that secondary oocyte dies and it's sloughed off in a female's vaginal fluids. Now, sperm have chemical sensors on them that help them to find the oocyte. A young man's sperm can make it to a female's secondary oocyte in as quickly as 45 minutes. An old man's sperm take about 2.5 days to reach that oocyte. So for an old man to get pregnant his partner, he must have to really plan for ovulation. About halfway down page 136, let's talk about female hormones for just a moment. The process here is similar to males. We see that GnRH, or gonadotropic releasing hormone, is initiated from the hypothalamus. That in turn causes the anterior pituitary to release follicle stimulating hormone, or FSH, and LH, which is luteinizing hormone. Now, finally, this term makes sense. Follicle stimulating hormone promotes follicle growth in the ovaries. Just keep in mind, a follicle is a ring of cells that surrounds an oocyte. So here's your oocyte in the middle, and it's got its own little ring of cells called the corona radiata. So when we're maturing the follicle, we're also maturing the oocyte inside. Notice that FSH also promotes estrogen production by the ovaries, while LH, luteinizing hormone, promotes ovulation of this oocyte from its follicle and the ovary. This cascade of hormone production ends up with FSH promoting the ovaries to release estrogens and progesterone. Notice that estrogens promote oogenesis, which is the maturation of a secondary oocyte. Estrogens also cause the endometrium lining of the uterus to thicken every month. And estrogen is also responsible for secondary sex characteristics in females, such as the growth of breast tissue, increased fat deposits in the hips and the breast area, and the growth of pubic hair and axillary hair in the armpits. Progesterone is an important hormone, especially for pregnancy to be maintained. You'll notice it prepares the endometrium for the reception of a fertilized ovum, and it prepares the mammary glands for milk secretion. In order for pregnancy to take hold and be maintained, our progesterone levels must be high. All right, so that should take us to the bottom of page 36. Let me take you on now to page 137. Let's talk there about the menstrual cycle. So a couple of new terms there for us. Menarche means the onset of menstruation. For a female girl, this occurs around the year age 12. That's a little younger than men or males go into their onset of sperm production. Males usually have an onset of puberty a couple of years later, 13 to 14. Menopause is the ending of menstruation. Technically, it's defined as 1 year without a menstrual cycle. So I want to mention to you something that I don't have clearly outlined on your worksheet, but there is this. There is an ovarian cycle that drives the menstrual cycle. So the ovaries ultimately drive what the uterus is doing. So even after a woman goes through menopause, let's say she's 65 years old, you've probably heard those stories where a woman has a baby at age 65 or even age 70. As long as we can wake the uterus back up with hormones, the uterus will go back into a menstrual cycle. So it's ultimately the ovaries that die in a female who passes through menopause. And when those ovaries no longer control the uterus stops its cycle, which means the menstrual cycle stops at the time of menopause. So there is a link here with the ovaries driving the bus. They tell the uterus what to do. Okay, so now that we've had that conversation, let's talk about the menstrual cycle. All right, so on page 137, a typical menstrual cycle lasts around 28 days. That may not be the same for every female. In fact, for one given female, that may not be the same every single month. Sometimes it's 25 days, sometimes it's 32 days, and this can vary for a given female or from one female to another. So this is just an average length of time. Now let's start with the beginning of the cycle, which is called the menstrual phase. This is the time when menstruation occurs. And technically what happens is the endometrial lining, called the stratum functionalis, is shed from the uterus. So with the decline in hormones like estrogen, for instance, we see the endometrial lining slough and be removed. So this process of sloughing off the endometrial lining occurs for approximately 3 to 5 days. And during this time, FSH levels begin to increase and follicles begin to grow for the next process, for the next oocyte to be ovulated. Once the menstrual cycle is over, we're entering a phase called the proliferative phase, which is days 6 through 14 of this cycle. During this time period, estrogen increases through a positive feedback mechanism that makes more luteinizing hormone. And finally, on day 14, that's a special day here because that is ovulation. So there's a surge of luteinizing hormone that promotes ovulation on approximately day 14. Now I should mention that no matter the length of a female's menstrual cycle, even if it's 32 days long, they say that ovulation typically will occur on approximately day 14. Now, when ovulation occurs, two things can happen. Either the oocyte is fertilized within the 24-hour period that it lives, or the oocyte dies. Okay, so we've got two pathways here that we can go. Let's assume here that we've got fertilization. So if fertilization occurs, then that follicle that was mature, which is called a corpus luteum, will continue to produce progesterone and estrogen that will help to prepare the uterus for the reception of a fertilized egg. Implantation in the uterus will actually take about 7 days. So if fertilization occurs on day 14, when ovulation occurs, then implantation will not occur until approximately day 21. Okay, and then about a week later, that's when the period should normally start. The menstrual cycle should normally start. Now, if fertilization occurs, that menstrual cycle will not begin. Let's also take a look at what happens when there's no fertilization. If no fertilization occurs, this drop in luteinizing hormone will cause the corpus luteum to degenerate. That decreases progesterone and estrogen. So it's the decrease in progesterone and estrogen that causes females to often feel crampy by the time their menstrual cycle approaches. Sometimes there's mood changes, swelling, things of that sort, bloatedness. This comes from a decline in some of these hormones that we experience toward the menstrual cycle. So let's talk about this image here. If you flip over with me in your course pack to page 138, a menstrual cycle similar to this one is pictured in there. So there's a lot going on here. Right here is ovarian cycle, and down here, of course, is menstrual cycle. So the ovaries are the driver of the menstrual cycle. They are telling the uterus what to do. So let's take a look. So let's start with the beginning of the menstrual phase. They're looking at day 0 here. That's the beginning of our cycle. And just notice the lining of the endometrium is being sloughed during that menstrual phase, days approximately 0 to 5. Following that is a proliferative phase up until ovulation, which is day 14, followed by the secretory phase. And that's when the endometrium lining is preparing for the reception of a fertilized egg. The body has no way to know whether or not fertilization has occurred, so it prepares every month, it plays house, as if a fertilized egg was coming to implant there. And if it did, it would occur approximately day 21. Let's also take a look at the ovary because that's what's driving the uterus to do its job. First, we have a primary follicle that grows into a mature Graafian follicle. This little thing inside, that is the oocyte. You can see it's ruptured out and ovulated at day 14. After that, we have a disintegrating corpus luteum. That's assuming there's no fertilization. Okay, and that will cause a decline in 2 hormones. Of course, we see those estrogen levels begin to fall off. And we tend to see those LH and FH levels fall off too. Okay, so take a look at the hormone fluctuations here. This peak of estrogen right before ovulation is a positive feedback loop. You know, the positive feedback loops enhance the stimulus, and the goal here is to cause a spike in luteinizing hormone around day 14. In fact, it occurs right before day 14 where ovulation is timed. So this increase in estrogen and increase in luteinizing hormone ovulates an oocyte, and of course, after that time period, LH and FSH tend to decline. You'll notice that estrogen levels will also tend to decline by the end of the secretory phase. But why do progesterone levels, why do they stay high? Progesterone stays high because they help prepare the uterus for what? Fertilized ovum. Okay, so only by the time you reach the end of the cycle, notice we're after day 21, there's a disintegrating corpus luteum by this point. Party's over. There's no fertilized egg this month, so all hormone levels drop off dramatically at the end of this 28-day cycle in preparation for menstrual flow, and then we start the whole process over once again. So just another image here for you to take a look at. Again, the ovarian cycle drives the endometrial lining's thickness along with these hormones here. And just another point, progesterone stays high during this second half after ovulation, while most of these other hormones tend to take a nosedive. Another interesting point here is that body temperature tends to increase at ovulation, just a trick some women use to detect when they're ovulating if they're trying to time when to get pregnant. Likewise, cervical mucus tends to thin around the time of ovulation. That allows for sperm to travel into the uterus. The rest of the month, the rest of those 27 days, that cervical mucus tends to stay thick and does not allow sperm to travel into the uterus. So to wrap up this information, let me talk to you about what happens if fertilization does occur or does not occur. If fertilization does not occur, the corpus luteum degenerates. It breaks down, and eventually, towards day 28, we're starting to see those progesterone and estrogen levels decline. Progesterone initially spikes after day 14 to prepare the uterus for a fertilized egg, but when there is no fertilized egg to be implanted, it's going to drop off as well. So we do see menstruation occur if there's no fertilized egg. If fertilization does occur at day 14 when ovulation is happening, then a zygote will be formed. It undergoes rapid mitosis and becomes a ball of cells called a blastocyst. It takes approximately 7 days for the blastocyst to travel to the uterus and find a suitable place to begin implantation. Implantation will often occur around day 21 of the menstrual cycle. That means that particular period will not come because implantation has been successful. So this blastocyst will rely on progesterone and estrogen levels increasing. Without these hormones, the blastocyst will not take hold and implant in the vagina, or in the uterus rather, and the blastocyst is lost in the vaginal fluids by the next menstrual cycle. So that means between day 21 and day 28, this blastocyst has to take hold. If it doesn't, day 28, there's where that menstrual cycle comes. A female may never have known she was pregnant that month. That blastocyst is critical for starting the process of a pregnancy. Just want to show you here, once again, the site of fertilization is the fallopian tube, but the site of implantation is in the uterus. So right here is a blastocyst implanting into the uterus lining. Excuse me, but up here you can see fertilization occurs in that fallopian tube. Got a zygote. It rapidly divides as it travels down here toward the uterus. If it is unsuccessful in implanting here, then it is sloughed off in the menstrual or the vaginal fluids. Female never has any clue she was pregnant. Thank you. That is the last video for this course. I've enjoyed having you.